Alright guys, welcome to video number 172. This one is on circle theorems, and it's the first 3 circle theorems that I'm going to introduce you to here. There are 9 of these circle theorems. Well, there are 8 technically, but I'm making 9, right? Because there's a nice extra one that you could know. Now the keywords are all to do with circles: radius, segment, chord, tangent, diameter, circumference, sector, and subtended. Subtended doesn't necessarily have to be to do with circles, but the radius is the distance from the center to the edge of the circle. So segment is made by an arc joining a chord, or a chord joining an arc. A chord is a line that goes from one point of the circle to another inside the circle. A tangent is a line that hits the circle at one point and then shoots off again. The diameter is the distance from one side of the circle to the other through the center. The circumference is the distance around the outside of the circle. The sector is a part of the circle where 2 radii join an arc from the center. And a sector, I just mentioned, and a subtended means it comes from that particular point. An angle is created from a particular point. Okay, oof, lots of keywords, and they're the same in the other video, so I won't describe them in that video, or the next 2 anyway. So basically these are things you need to learn. You have to learn what these circle theorems are. You need to know this one, this one, this one, and then another 6 after this, right? They're all right. They're all right, easy to remember. And I've written these words underneath them, all right? They are what you're going to give for reasons. These words down here, all right? With the exception of one of them, which is the last one in the last video. But angles in a semicircle equal 90 degrees. Basically, when you've got a line that is the diameter, and you've got a line that comes off of it, and another line that comes off of it, and creates a triangle, that angle here at the top of it, so the angle that comes off of the 2 ends of the diameter, this angle that's created here is always going to be 90, okay? And you can see this triangle does exactly the same thing. This angle is going to be 90. That's an angle fact that we can learn to do with circles, and therefore it's referred to as a circle theorem, okay? There are other angle facts that we might need to apply to these problems as we go through them. All the other angle facts still apply here, okay? Now, number 2 is angles in the same segment are equal. All right, so this chord here has created a segment here and a segment here, large segment and small segment. All right, and then we've got the angles that are in the same segment. So this angle here and this angle here are the same as each other. Sometimes this is referred to as the bow theorem because it creates a bow shape. All right. And then the last one, we've got a tangent and a radius, and when a tangent meets a radius, it creates a 90-degree angle. Okay, so 3 circle theorems that are very useful to know, and I've got 3 problems to solve that are including these things in this video. So question number 1 asks us to indicate the 2 points that form the diameter of the circle, and then we've got to give a reason for the answer. Okay, well, this one is to do with circle theorem number 1 here, angles in a semicircle. All right, so if we added 5 and 95 together, it might be difficult for you to see what they are. All right, but 5 plus 95 is 100. Therefore, this angle here is 80. All right, because angles in a triangle equal 180 degrees. So it's not either of these 2 lines. All right, it's not that line, that line, that line, that line. Okay, it's really difficult to see what those points actually are. So I'm just going to zoom in and just see what the letters are on them. So that's something F, G, something. I don't know what that letter is. Doesn't really matter because it's not either of those lines. Okay. If we were looking at this one here, A, D, and C, A, it's going to be either one of those 2 lines. We'll decide which one it is based on what angle is 90 degrees. So that's 10, that's 80. So that adds up to 90. This one's the 90-degree angle, okay? So using that angle fact up here, it must be A to D, all right? A to D. AD is our answer. That's our diameter of the circle, because at the top of that, the 2 lines that join together at that particular point there would always create that 90-degree angle. And the reason that we can give is angles in a semicircle equal 90. So we'd write that down. Angles in semicircle equal 90 degrees. All right, that's our circle theorem that we're stating as our reason. All right, relatively simple, but tricky if you didn't know that circle theorem. Right, let's have a look at the next question. Now this one asks us to prove that QS is not the diameter of the circle. All right, I'll just have a little zoom into that one as well so you can see it a little bit better and I can see it a little bit better. All right, so QS is there to there. All right, that's not the diameter of the circle. All right, so if we're going to prove it, we need to use these circle theorems. And we've also got a little dash on that line there. Hopefully you spotted that. There's a little dash and there's a little dash. So that means that this triangle here, PSX is an isosceles triangle. These two lengths are the same. Therefore, these two angles are the same. All right, and we can work those two angles out. All right, so we might as well start there. All right, so 180 degrees minus the 50 degrees is 130 degrees, and then 130 divided by 2 to get our two base angles there equals 65 degrees. All right, so that angle is 65 degrees, so is that angle there. All right, might be useful for us to know. Well, will be useful for us to know. But we also can use this circle theorem here, circle theorem number 2, because we've got a bow going on. All right, now these points here, this point, this point, this point, this point, all touch the circumference of the circle. It's not the bow theorem, it's not the angles in the same segment theorem, unless they do that. Okay, they have to touch the circumference, these 4 points. Now this 27 here is the same as this angle here, 27 degrees, because angles in the same segment are equal. Okay, now what we've got as well is this point and this point. Remember, we've got to prove that here to here is not the diameter. Okay, 65 plus 27 does not equal 90. All right, and that's what we would need to equal for this to be the diameter. Okay, so let's just kind of structure that and make it make sense. So I'm going to say the angle, I can't remember what letter that is, ultimately QPS is not equal to 90, all right? But first of all, XPS, so angle XPS equals, don't need to use an algebraic X there, do we? That's a letter, all right? Angle XPS equals 65 degrees, okay? And the reason for that is isosceles triangle. So that's what we would write down. There's our reason for our answer there. We need to prove it, okay? And then angle QP something, R, let's say that's R, angle QPR equals 27, or QPX, 27 degrees, and that's because angles in the same segment are equal. All right, so if that's the case, then 65 plus 97, so angle QPS, there we go, QPS is equal to 12 plus, that's 92 degrees, okay, and 92 degrees is not equal to, equal symbol with a line through it, is not equal to 90 degrees, okay, therefore QS is not the diameter. I think that's enough for the proof of that using the circle theorem and the isosceles triangle fact. All right, now let's move over to the last question, last problem that we've got here in this first circle theorems video. Got to work out the value of x and y and give reasons for the answer. So this looks a lot more complicated, a lot of stuff going on in here, but we can pick out some things, right? We can actually pick out that here, and this might not be useful, right? But there's a 90 degree angle because that's definitely the diameter, and it would say this in the words as well. I just didn't put these words in the question, by the way, right? But C to O to A is the diameter. O is the origin. O is the center of the circle, right? That's the diameter. Therefore, this line and this line have created a 90 degree angle here. We can also see there's a bow theorem going on here. There's angles in the same segment theorem going on, all right? So there's a little segment here, right? But it's this segment here that we're interested in, right? And that's this angle is the same as this angle, so that must be 30 degrees, okay? That's actually going to help us work out x, because I can see that CBA or ABC or ACB, whatever, right? that is a triangle, okay, and it's 180 degrees inside it. Well, if that angle's 30 and that angle's 90, then that's 120 altogether, and therefore we can work out what x is. Okay, so let's say for two reasons, there are going to be two reasons, so we'll do it one angle at a time. CBA or ABC, angle ABC is equal to 90 degrees. Okay, and that is because angles in a semicircle equal 90 degrees. There's one reason. All right, the next one, angle BCA equals 30 degrees, and the reason is angles in the same segment. These are hard to spot as well, by the way. They are equal, okay? But once you've spotted them, draw it on the diagram, write your reason down next to it, okay? Write down what the angle is as well in the words in the proof. So that must mean that, so therefore x equals, what did we say? That's 120, so 60 degrees, okay, for these two reasons, okay? That'll do. Now, y is going to be got by doing some more stuff here. We've got to use this, and there are other ways we could do this as well, right? But we'll use this fact here, that a tangent meets a radius at 90. So we know that 90 is this angle here, okay? So y is part of that 90, all right? Now, if we can work out what this angle here is, and what this angle here is, possibly, or what this angle, we're going to work some other things out, all right? So let's just have a little look at this one, because it is hard to spot sometimes what you have to do. So hold on. Okay, in this one I'm going to have to introduce you to another circle theorem here. Or this is the one that isn't really this O to D and O to A, right? They are the same length. They are both the radius. All right, which means that this angle here can be got. We can get this angle here. If we do 180 take away 70, 2, all right, and that's going to be 108, and then divide both by 2. So I'll just write down what I'm saying there. So 180 minus a 72 equals 108, and then 108 divided by 2 equals 54 degrees. All right, so this angle here is 54 degrees, okay, because of an isosceles triangle rule. So we're going to say that O to A to D, so angle OAD, let me just write down x equals 60 down here in the answer space. OAD, and I can get rid of everything else. Remember those reasons were for that first one. Not enough room to write stuff down, so get rid of that. Angle OAD equals 54 degrees. Reason, isosceles triangle. Okay, now if that's 54 and we know that OAT equals 90, and our reason being a tangent meets a radius, at 90 degrees, okay, therefore y equals 90 minus 54. So you take away the 54, so that's going to be 36, isn't it? Yes. So y equals 36 degrees. All right. Very, very tricky, that problem. We've used a few different angle facts there. In fact, we've used two for each, haven't we? We've used two different ones for each circle theorem. Sorry, for each missing angle, all right? And we used all the three that were in this video and an extra one, which will be in the next video as well. And I can't really avoid that, unfortunately. They do mix up these circle theorems. Like I said, there's not only one way, just like with other angle facts and angles and parallel lines and things like that. There are lots of different ways in which you could solve your angle problems, right? So I hope you've enjoyed watching me solve these problems. They are tricky. They do take a little while. I even had to pause that last video. just have a little think for a couple of seconds about what I was doing, because I didn't want you to be watching me thinking. That would be very boring. All right, so hope you've enjoyed watching that. Very tricky topic, circle theorems. Lots to learn, all right? Top end stuff. Grade 8, possibly even moving on to grade 9 with that sort of last question there, all right? So I hope you've enjoyed it. I hope you enjoyed watching me solve maths problems, all right? Peace. Take care.